Good evening. Welcome to the QCIS channel, where you get your daily dose of science, technology, engineering, and math. And if you're looking for the Mind of STEM channel, this is it. I just rebranded the channel because I didn't want to get hit with a copyright strike or trademark infringement from using the STEM logo. So I started utilizing my business logo. Now, tonight's topic is going to refer to the field of construction. Now, I work as a civil engineer, and currently I inspect construction projects for HWC engineering. Now, earthwork is going to be the title of tonight's video. So the whole topic is, why is earthwork important? Why is earthwork important? Well, when you are doing any type of construction, you're going to be moving a lot of dirt. And a facility, no matter how big, no matter how small. Now, what do you do with the dirt, or let's call it soil material, after you remove it? Well, you may store it as long as it's not contaminated. And when I say store it, you may reuse that soil as a backfill. Now, when it comes to soil, there are different fields that you can utilize the calculation of soil in courses. There's geotechnical engineering, there's soil mechanics. I actually took both. And I'm going to show you some of the equations that they come up with when it comes to soil. Now, of course, water is at 62.4 pounds per cubic feet. Salt water or seawater is at 64 pounds per cubic feet. Those numbers are very important because when you do soil mechanics, you're going to always see those numbers. Now, some examples of excavating are trenches, footings, and also tunneling. Those are areas that are also enclosed. And the reason why I brought those three areas up is because there's a chance of a lot of cave-ins. So when it comes to trenching, you use a trench box. When it comes to deep trenching, you use benching. I prefer going 2-to-1 or 3-to-1. And when it comes to tunneling, use anchoring or shotcrete, any type of concrete. Now, they're not really building too many tunnels. Tunnels, you use a tunnel boring machine. But regardless, excavation is very important. Let me share my screen and show you a little bit of excavation here. If I can find it, I will definitely find it for you. All right, bear with me. Because, a lot of us, when we deal with soil, many of us don't understand. And just bear with me one moment. I am trying to share this screen. Okay. All right. Here is PowerPoint that I'm going to show you all. Here we go. We finally got it working after technical difficulties. Now, the information that I'm going to present comes from my construction estimation book. So Pearson is the company that writes the textbook, Construction Estimating with Excel. Now, what I'm going to show you is chapter 16. This is important. This is when I get to earthwork. Now, when you deal with earthwork, there's going to be characteristics of soils. And within that soil, you're going to have wet unit weight, or we call it wet density, which is the density of water and solids. And you're also going to have dry unit weight, or dry density, density of the solids, unit weight of water. Now, the weight of water in 1 unit or cubic foot of soil. Then you have your water content. That's your weight of water or weight of solids. You get your swell and shrinkage. Now, when we deal with soil out in the field, we always deal with compaction, and we test the soil every 8 inches to a foot. Some still use nuclear density gauges, some use electrical density gauges, but what you want to get out of the soil is a compaction. Most of the time, we want to get 95%, particularly if it's under a structure like a building or a road, because there's going to be loads on it. Now, soil is going to come compacted, it can come loose, and you can use soil for building embankments. Now, soil has swell. Why? Because it increases in volume when it's being excavated. Now, there is a formula for swell, and swell is a percent. It's called the percent swell. And what you're going to do, you're going to divide your dry density or your bank density unit weight by the loose density, subtract 1, and you'll multiply it by 100. Now, when you have a decrease in volume, because soil is often compacted, that's called shrinkage. Now, shrinkage also has a percentage. That's your dry density or your unit weight divided by your compact dry density unit weight. Now, again, if you have the book, Construction Estimating using Excel, all of the volume and density conversion equations are found in table 16.1. Now, when it comes to the excavation of soil, there are geometric shapes that you are going to use, and what you have to do is determine the volume of each of those shapes. And once you do, you're going to get a total volume. It's known as the geometric method. The most common one is when you do the width, length, and depth. That's called the average width depth, or some of us call it the average in method. I like this method because it's straight to the point multiplication. You deal with average width, average length, and average depth. Now, when you do average depth, it doesn't include side slopes. The average in method, this is when you use your length, you multiply it by your area 1 plus area 2, and you divide it by 2. Now, when you deal with areas, you're dealing with the cross-sectional area. And the length is the perpendicular distance between the two cross sections. Now, what do I mean by perpendicular? When something is perpendicular, like, okay, I have my hand right here. Perpendicular means that you're going to form a 90-degree angle. See, right now I have one hand going in the X direction. The hand going in the Y direction forms a 90-degree angle. That's perpendicular. This is parallel. Number of individuals don't know how to distinguish between the two. When you have parallel lines, you don't have any angles. Now, you can have 2 parallel lines and you can cut it in half with a perpendicular bisector, which is going to form 90-degree angles. But that's a math topic. Now, of course, the average in method. The average in method is a very tough method because you are dealing with areas of cross sections. You have a long formula to deal with. Again, L, which is the length, must be perpendicular to all of the areas. Now, when you use the average in method or any geometrical shape, you should have stations. Stations are good locations. I'm going to do a video telling you what stations are. And I may do some problems. May do them in Excel for you. You also have the modified average in method, which is basically the same. You're going to have two areas. You're going to have perpendicular distance between the cross sections. Now, what you do with this formula, you're going to add two areas. Then you're going to add the same two areas, and you're going to take them to the 0.5 power. The 0.5 power is the same as taking a square root. And then once you do all the information in the parentheses first, you add the areas, then you multiply it by the length, which is your perpendicular distance between the cross sections, divide by 3. Then you have the cross-sectional method. Now, the cross-sectional method is when you utilize the grid method. Everything is equally spaced. Now, a lot of this is more in touch with engineering than it is with estimating, but you still have to estimate excavation if you're a contractor. You have the cross-sectional method. Cross-sectional methods include cut and fill at each grid or intersection. Now you have the cut/fill, that's equal to the grade proposed minus the grade existing. Now, when you have a positive number, see grade stakes out there. If you see a C 1.5 on a grade stake, that means cut 1.5 feet. Now, a cut is when you take soil out. A fill is always going to be positive. You're going to have an F, fill 1.5. What you're going to do, you're going to add soil. Now, you already have an existing elevation. So in the field, to level everything out, you're going to have some cuts and fills. The cross-sectional method, you're going to deal with grades. Graded intersection, contour lines, second contour lines. This is between the intersection and first contour line. This is between the second and first contour line. So you have what we call a grade P, which is equal to your grade 2 minus grade 1 times your distance, P minus 1 distance, P minus 2 plus grade 1. Now, I am actually going to do some of these equations in the future, and I'm going to show you how I got all the information. But right now, I'm just giving you some of the equations that take place during excavation. Again, the cross-sectional method, you're dealing with cuts and fills. Again, a negative is always going to be a cut. A positive is always going to be a fill. Now, when you're dealing with an intersection with a cut, it's got to be positive, and an intersection with a fill is going to be positive as well. Again, you separate the cuts and fills with a 0 line. You have an area of cut, You have your zero line. Your zero line indicates that there's no cut or fill. Then you have your area of fill. This is when you balance out your equations. It's almost like an accountant. Okay, you're going to calculate the volume of cuts and fills, and you're going to do that separately. Now, the volume of cut equals the area of cut times the average cut, and the volume of fill equals the average fill times the area of fill. And once you find the product of both of those equations, you're going to total out both your volume of cuts and fills. And one of the most important aspects of excavation is backfill. Backfill is used on a lot of construction projects. It's excavation, footings, and foundation. Now, again, when we do any type of equations, again, what is excavation? Go back in there, share my screen again, and try to find some excavation problems for you, because it's very important that you understand what's going on if you are going to go into engineering. Now, one thing I wanted to share with you, what is excavation? Well, I'm going to say excavation definition for construction. All right, excavation is the process of moving things like earth, rock, or other materials with tools, equipment, or explosive. It includes earthwork, trenching, wall shafts, tunneling, and underground excavation has several critical purposes, including exploration, environmental restoration, mining, and construction. Now, you also, I'm going to tie it into geotechnical engineering. Now, geotechnical engineering is a branch of civil engineering that actually is concerned with the behavior of earth materials. It uses the principles of soil mechanics and rock mechanics for the solution of its representative engineering problems. And another topic that you're going to hear is geology. Now, geology, we deal with the study of the earth. Now, plate tectonics, we deal with rocks, sediment, and different types of rocks like igneous rocks, sedimentary rocks, geophysics is involved, planetary geology. All of these are tied in to one another. But when it comes to excavation, why is excavation important in construction? Well, the importance of excavation. Well, critical purposes. It's critical because you need to utilize excavation to create foundations, reservoirs, and roads. Again, if you're interested in doing some excavation, try going to a contractor. You have to be very skilled with the equipment. Now, what I did today was give you an overview of what excavation really is. Now, again, it's very important that you understand the mathematical formulas as well. Everybody thinks that getting out there working in a field takes no brains at all. You have to understand what you're cutting and what you're filling. Then you have to compact soil. Now, the reason why excavation is important, particularly in construction, is because an estimator is going to estimate how much material they have to remove, and they may remove that material off-site, and they may replace that material. Excavation costs. Excavation is a volume item. You look at every DOT specifications, it's usually under Section 200. But again, wanted to give you an overview on why is excavation very important in construction. And if you need more information, just watch this video, comment, and I will produce more, because it is construction season, and I'll be out there in the field doing more field inspections, and I will show you how to read plans. Now that concludes this topic on why is excavation important in construction. If you like what I just presented, please comment, share, and subscribe. And if you like more of the political and social content, you check out my other channel, the 411 Talk Zone radio show on YouTube as well. Now, if you can't find the 411 Talk Zone radio show or the QCIS channel on YouTube, you can find both channels on Twitter. Now, with the QCIS channel, since it's more professional and educational, I take it one step further and I place it on LinkedIn. But once again, I want you all to like, share, and subscribe to the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. I want to thank you for listening. Till next time, my name is Leon Jones. I want you to have a wonderful and gracious evening.